Good evening. Welcome to the Mind of STEM channel. On this channel, give you a daily dose of science, technology, engineering, and math. My name is Leon Jones, and during this episode, I'm going to teach you project planning and control. So tonight's topic deals with project planning and control. Again, it's project planning and control. Now, again, this work that you're getting is actual work that I've done. Now, you're going to see some of my grad school work. And here's a project that I did when I was at the New Jersey Institute of Technology. You can see the date on it, the fall of 2012. It was a group project. It was from my CE 671 class. And what it was, we were dealing with an expansion of a New Jersey transit line from Palisades Park, you say in that area, to Atlantic City. Now, of course, when you plan a project, you have to give an idea of cost, location. You have to put environment into the project, who's going to build it. So when you are dealing with project planning, there's a lot that goes into it. Now, overview, we give you the background, project alternatives, societal benefits, future research, and of course, references. Just bear with me. All right. All right, here's the background and motivation. It is from the New Jersey Transit, which they call it NJ Transit. And when you do project planning, you're going to have to put some maps in there. Maps are very critical because maps give you an idea of the existing structures. I like using color, so I use color here. You're going to look at the connections from Newark, New York, Philadelphia. These are all of your passenger rail systems. Now, the background, okay, and motivation. The background and motivation are as follows. Well, there's an existing New Jersey transit line that crosses New Jersey from Philadelphia to Atlantic City, but there's no direct transfer to the other New Jersey transit lines. So approximately 33 million people throughout the tri-state area visit Atlantic City by automobile every year. Now, depends on what you call the tri-state area. When you are in North Jersey, the tri-state area is Connecticut, New Jersey, New York. And when you're in a tri-state area in South Jersey, it's Delaware, Pennsylvania, and New Jersey. And you must understand that visitors play an important role in the city and state economy. However, the high volume of drivers contribute to the congestion and poor level of service of New Jersey's highways. Now, right here is the information that goes in the planning. Why are we doing this? Okay, many visitors will take other modes of transportation, including rail to Atlantic City, but only if it's convenient to do so. Is there an optimal rail layout that could get the higher number of visitors to Atlantic City off the roads and on a minimal budget? So, planning, come up with an initial process. So what we said we were going to do was we were going to design two alternative rail lines that connect the current Atlantic City rail line to the rest of the NJ transit rail system. And number two, We also have to have a goal. And the goal was to choose the more feasible alternative based on demand by optimizing the amount of stops to minimize the total cost of operation. All right, now, here was our proposal. Here's the existing New Jersey transit line from Philadelphia to Atlantic City. Well, coming from Point Pleasant, which is up above Palisades Park, this was our first alternative proposal. We're going to come right down here, right along US 9, and connect the existing New Jersey transit line to Atlantic City. That was alternative number one. Number two, we were going to come from the state capital, which was Trenton. Now, this is all planning. As you see, when you plan, you have to come up with alternatives. Now, project alternatives. When you're planning, one of the ones you're going to always have is alternative zero. Now, alternative zero is a no build proposition. Now, no build, what happens? You use current infrastructure such as building facilities, railways, and highways. Alternative one, minor improvements for railway from Trenton to Atlantic City via Philadelphia, total length 73 miles. Alternative two, build a new railway system from Bayhead to Obsescon, which is a total length of 58 miles. Now, of course, we talk about alternatives to the system. Well, when we deal with no changes, these are actual numbers that we researched and came up with. Now, for the Atlantic City Brigantine connector, we're looking at $330 million. The construction cost of the AC Expressway was $48 million, $26 million for a 6-story parking garage. Host HMS, which is a Marriott facility, $5 million. Renovations, $2,500,000. Right around $8,500,000 for operation cost for buildings. Maintenance building, $2 million, and then just over $2 million for maintenance cost for roadway. Total cost, if we had done the alternative zero, would be about $420 million, or correction, $428 million. And this is exactly what goes into planning with the alternatives. Now, when we chose the second option, invest in the current system, minor improvements to railway from Trenton to Atlantic City, well, you find that rolling rail stock was close to 300 million, 75 million for leases and contracts, etc. And you had for passenger rail facilities, 26, almost 27 million. Casino revenue, because of course there's a lot of casinos in Atlantic City, 19 million, and rail support facilities, 10 million. Now, if you look at the first two, the first one that I did with all the renovation, it came up to 420 million. Now this one, just doing some minor renovations, we come up to 451 million. And see, some people believe that the alternative zero, which is the no build option, is going to be the best way to go. You're going to find out that it's not. Now, our third option, alternative two, was to build a new railway system from Bayhead to Obsescon, New Jersey. Now, to lay heavy track would be right around 67 million. Rail passenger facilities, 96 million. Right of way, 65 million. Park and ride, 52 million. 26 million for passenger vehicles. Engineering services, we're going to put almost 29 million in it. Bridges, 10 million. Track material, just over 2 million. And just over 6 million for maintenance of railroad. Now, when you total all of that up, that came up to 354 million. Now, if you looked at the no build operation, that was 428 million. So What I saved here was roughly, and I'm just rounding off numbers, I saved $74 million with alternative two. About $97 million I saved from alternative one. And when you do planning, you also have to do a lot of estimation as well. And okay, altogether, we chose alternative two as the most alternative economically. Why? Because it costs less to build a new facility than to upgrade existing facilities because the new facility isn't occurring costs since it's not in operation. Also, a new system reduces traffic on existing highways and wait times at existing rail systems because it is shorter in length. So you don't have to stop in Philadelphia for a transfer. Common sense goes into planning. This is what I'm teaching here. All right. Alternative two. Again, here's why we chose it. Because it gives one location advantage over the other locations by attracting residential and commercial development would also occur elsewhere within a region. Now, that is good because the more densely populated that area becomes, the more money the system makes. So, in other words, the system will incur, it's going to incur cost to build, but it's going to get its money right back because more businesses and more people are going to move in that area. And again, when you have building of new projects and of course subdivisions, it will create more jobs, ridership, and revenue for NJ Transit. So they can spend the money to finance upgrades to the existing infrastructures such as bus terminals and other rail systems. Also, a new rail system would increase the overall productivity by reducing total local transportation costs. That includes costs to customers, businesses, and government for vehicles, parking, and roads. And it also provides a catalyst for more clustered development patterns that will provide economies for agglomeration, which in turn, it will reduce the cost of providing public services and increase productivity due to improve accessibility and network effects. Now, although these productivity benefits are difficult to quantify, they can be large. So just a few percentage increase in property values, a few percentage reduction in automobile and parking costs, and a few percentage increase in business productivity in a community can total hundreds and millions of dollars. Now, again, cost savings. All right. And this is why I like using numbers and blow it up a little bit so you can see the numbers that I am putting out. Okay, just bear with me. Okay, for operational cost savings, we have 146 million, productivity, 157 million, safety benefits, almost 50 million, pollution decrease, 6 million. So total benefits, when you total everything up, 359 million. Project costs, 354 million. So you have total social net benefits of $4 million. Again, the trip. When you use the bus, now this is going to be cost. It's going to be round trip, $56.50. Travel time one way, 4 hours. How many accidents per year do you have when it comes to bus? You have 96. Fuel consumption, 8.8%. Now, when you use your private vehicle, certainly the travel time one way is going to be less, but the cost of a round trip is going to be $71.46. About 23,600 accidents per year and a lot of fuel consumption. It comes in at 88.2%. Now, when you use the rail, $43. So you're getting a reduction already from both the bus and the private vehicle. Travel time is also a reduction, 2 hours, 40 minutes. You don't have that many accidents per year, 78. One is too many, but it's not as high as the bus accidents or private automobile accidents. And you only have a 3% fuel consumption. So basically, when it comes to flexibilities, bus routes can change and expand when needed. For example, routes can change if a roadway is closed or if destinations or demand changes. Again, requires no special facilities. Buses can use existing roadways and general traffic lanes can be converted into a busway. So more suitable for dispersed land use, and it also can serve as a greater rider catchment area. So several routes can converge on a one busway, reducing transfers. So for example, buses that start at several suburban communities can use a busway to a city center. And with that, you're going to have lower capital costs. Also, transit will be used more. So you're going to have people who are going to depend on bus service. And again, when it comes to service improvements, they provide greater benefits. Now comes the rail. Rail tends to attract more discretionary riders than buses. Greater comfort due to larger seats with more legroom, more space per passenger, smoother and quieter ride, more support by voters for rail than bus improvements, greater maximum capacity. And see, with rail, it requires less space and is more cost effective on high volume routes. Greater travel speed and reliability, where rail transit, it's basically grade separated. Also, when it comes to land use, it's got more positive impacts. Rail tends to be a catalyst for more accessible development patterns, like increased property values near transit station. There's less air and noise pollution, particularly when electric powered. Rail stations tend to be more pleasant than bus stations. That's why rail is preferred where transit vehicles congregate. Again, this is how you plan. Again, I've set the map. This is our second choice, final proposed layout. And you can see all of the stops. Also, total population in the areas. Bayhead, Brick Township, Toms River, Lacey, Bernagat, Stafford, Eagleswood, Port Republic, Callaway, Obsescon, and of course other drivers to AC. Again, you look at your isochrones. There are all your stops. And you have 10 stops. Now, when we deal with planning as well, never forget the environmental impacts that you have to consider. So per the Environmental Policy Act of 1969, all projects requiring major federal funding must have an EIS, and that's a environmental impact. Now, in 1970, every European citizen traveled on an average distance of 17 kilometers per day. Now this was back in 2012. So then it was 35 kilometers per day. So developing countries and increased access to wealth, that's what you also have. And vehicles on roads continue to increase while fossil fuels decrease. And when I tell you about data, you always want to get a trend or you want to get some type of graph. So what I did is I came up with a graph, land uses for road versus rail station. Now, on the x-axis, I have passenger car, bus lane, and rail. And on my y-axis, I have persons per hour going from 0 to 10,000. And you can see with rail, we're all the way up to 9,000. Bus lane, separate, 5,200. 1,500 for bus, and passenger car 200 people per hour. And that's why I choose rail. Also, some of the other items that you must consider: sea level, a correlation between temperature increase and sea levels rise, more extreme weather conditions. So you have to deal with CO2, health implication of emissions. So remember something, train is diesel, but look at solar as a future state. And again, assumptions, because during planning, you're going to have some assumptions. Demand density will be based on population data from census as well as historical data. Passengers use the rail line as a round trip. So the number of passenger seats and operating speed is based on the characteristics of the single level common rail car, which is frequently used for NJ transit. Also, a user is willing to drive an average of 10 minutes to a train station in order to park and take the rail. Average driving access speed is 25 miles per hour. So therefore, a circular isochrone of radius 4.17 was used. Now, finally, we get the values for user weight, access, and in-travel cost vary in value based on the planner's understanding of user preference. Now, when you also plan and design for a project, we look at the existing infrastructure and what it's going to cost to either renovate it, maintain it, or provide a new service. But one thing you always have to look at is, how is this going to affect the future? So I'd say with any type of new infrastructure, including a railway on this project, you're going to have population growth. So that means the level of service on existing highways is going to grow. So that means highways are going to be over capacitated, which we deal with level of service. You want on a highway, a good level of service is A or B. A terrible level of service is E and F. So ridership on existing highways, that's also going to be a problem while the project is actually being constructed. So again, going back, when we do future research on designing a project, look at population growth, level of service on existing highways, ridership on existing railways. Will another project in a planning stage be beneficial? Will our alternative breakdown be beneficial during a 3 to 5 year period? Now, we may also have to come up with a BC analysis, which is a benefit cost analysis against the existing rail structure from Trenton to Philadelphia to Trenton to get the most benefit at a minimum cost. Again, when it comes to any type of infrastructure, you're going to have to get politics, environmental impact statements known as EIS financing, right-of-way concerns and issues, and of course, safety and security, and make sure it's going to all work, right? Collect real survey data in order to provide a more accurate estimated ridership by utilizing utility functions such as logic model. And the model can also include estimated fare to determine if the line would be economically beneficial to New Jersey Transit and of course, the state of New Jersey. And again, here are all my references that I got for this planning. And again, when it comes to planning any project, you have to take all of the constraints: cost, environmental impact statements. You have to look at existing infrastructure. Also, you have to look at who's going to do the work. Is it going to be a private-public partnership? Is there enough money during that fiscal year? How long is it going to take for the project to get approved? And see, road projects have a lot more politics behind it. Let me just say transportation projects. They have a lot more you have to deal with because of the environment. And you have to look at going back to the politics who's in power. Now, Republicans generally want infrastructure. Democrats want existing infrastructure. Republicans want businesses. They want growth. Some Democrats want it, but they think the no build option would be the best. Now, I'm not going to be biased. I'm going to cut it right down the middle. Project planning, it goes hand in hand on what the benefit is. We don't know what the benefit is until the infrastructure is actually built. So we're taking numbers from existing facilities and we're compiling them and we're getting the cost. Again, we're compiling numbers from existing facilities and we're using assumptions based off what we have now to see if it's going to be feasible to build a new system. And that's what you have to go through when you're planning. Also, you have a checklist. Some call it PS&E, Project Standards and Engineering. But every state is different. But remember something, all states get their funds from FHWA. And then once the project is completed, all of the records are sent back to the Department of Transportation. They're reviewed by the district, and then they're stored away for 7 to 10 years because the Federal Highway Administration, they can come and audit all the projects so they can see where their money has been going. Because if you don't spend the money correctly, you won't get any more money. So again, when it comes to planning a project, basically what you are looking for is how to plan for the benefit of the citizens within your state. Look at the advantages, look at the disadvantages. Overall, it's about the health and welfare of your state. Now, thank you for viewing this content from the Mind of STEM channel. On this channel, you get a daily dose of science, technology, engineering, and math. Now, if you cannot find me on YouTube, you can look me up on Twitter and, of course, LinkedIn. And once again, I thank you for viewing this topic on how project planning works. Again, like, share, and subscribe to this channel, the Mind of STEM channel. On this channel, get a daily dose of science, technology, engineering, and math. And remember, all the information that you are saying I did comes from my thinking. Of course, this was a group project, and I will be doing more projects on this channel because it's very important to understand the advantages of science, technology, engineering, and math. Until next time, my name is Leon Jones. I want you all to have a wonderful and gracious night.